Today we discuss the experiment of checking dimensions of part using slip gauge. Aim of the experiment to measure the taper angle of given specimen using different slip gauges. Apparatus required, these are the apparatus required. We have to calculate the different dimensions of the slip gauge values. So like slip gauge and surface plate and sine bar and by using vernier height gauge, and it is slip gauge sets. Then we are always used along with sine bar as the device for the angle measurement. Then they may be used the reference standard for transferring the dimensions of the unit length from primary standard to gauge blocks of lower accuracy and verifications. Then graduation of measuring apparatus. These are high carbon and ground and lapped rectangular blocks by using the different slip gauges. So having cross sectional area is 30 mm and 10 mm. Their opposite faces are flat, parallel and accurate to the steel distance apart. Pressed together with a slight twist by hand, they will ring together. There will be a remain frame attached to each other. They have supplied in set of 112 pieces of the down to 32 pieces. Due to the properties of slip gauge, they are built up by ringing into the combinations which give size varying by the steps of 0.01 mm, and the accuracy of the order is 0.0025 mm. So the finally slip gauges with the three basic forms are commonly found. There are rectangular, square with center hole and square without center hole. Then procedure of this experiment. So first we can considering to clean the surface plate, then plate the setup with the surface plate, note down the dimensions of the different slip gauges available. Then for the given angles to be calculated by the slip gauge, then bring all the selected slip gauge together to combinations of give the height. So place the sine bar with the contact roller on the top of the combinations of slip gauge on the surface plate to measure the build up the angle by the uncertain accuracy. So if any gaps or angles to be using by the calculate by using the gauges are to be available. So this diagram will shown here. It is a slip gauge sets arrangement in different nearly standard pieces 112. In our lab we have to considering as the slip gauge set is 132 piece of the slip gauge sets. So shown the diagram is it is a 10 mm and it is a 3 mm die of the slip gauges. Then formula used to be here, sin theta is equal to h by l, then theta equal to sin inverse of h by l. So we have to calculate it calculated for the where values are theta is taper angle of the workpiece, then h is noted as height of the assembled slip gauge, then l is noted as the length of the sine bar, where h is required slip gauge combination in mm and l is spacing between the rollers in mm. Okay, so these are the tabulations to be noted here. In length of the sine bar is standard length, then height of the slip gauges inserted. So there are different types of slip gauges we have to considering to be two readings, so like 75 or 50. Then taper angle we have to calculate it by using this formula. So for the component 1 it is a slip gauges ranges. How we will calculate for this height slip gauge? Okay, so now we have to calculate by using the different slip gauges the ranges from 50. So this ranges of the slip gauges it is 50 mm. Then we have to fixing by the sine bar by using the surface plate and also vernier height gauge. Okay, so now we have to calculate by the height of the slip gauge. It should be as length of this length of the sine bar is value is 150 mm, and the height of the slip gauge is it should be a standard one value. So there is no need, it should be an 50 is getting. How will you get from the 50 from this reading by using the vernier height gauge? It is 0 to 80 to be noted here. 0 to 80 it should be noted here. Okay, so here is the height will be an eliminate for this eliminate for the vernier height gauge. So that's why the 30 mm it should be a more than from the slip gauge. Okay, so that's why we have to reduce the value 80 minus 50, 80 minus 30, that is value is 50 mm. It should be a standard value of the slip gauge. Okay, then the finally we can calculate by the taper angle. So taper angle value already we know that it is a sin theta equal to h by l, sin inverse of h by l value. So we have to calculate it by here theta sin inverse of h by l. So sin inverse of 150 is the height, then length of the sine bar is 150 mm. It should be an standard one. So we have to calculate it by here also. So shift and sin inverse of h by l, so that is 50 divided by 150. Then we can calculate it as the degree again. So 19.28 is the reading of the first slip gauge. So that is the ranges of 150 mm. So similarly we have to calculate it by the 25 mm of the slip gauge. So finally, result of this experiment. So thus the taper angle of the given workpiece are determined using slip gauges as follow. Taper angle for the component 1 50 mm and taper angle of the component 2 is 20 mm.